All right, so for Chapter 7 review, our first focus is on the 7, 1, 2, and 3 sections. And I started out my review work just on line paper. In the first problem, it says find the sum of the measures of the interior angles on a regular 30-gon, and then it asks for each interior and each exterior. Now, exteriors are always out of 360, so if you have to get into each interior versus each exterior is always going to be the easy one. Take 360 degrees divided by the number of sides. So that'll get you started with that. Anytime it's exterior. So then in interior, what we've got to figure out is if it's 30 sides, we do 30 minus 2 times 180 to get the sum of the interiors. So that's 28 times 180, and that's giving me 50, 40. So we need that, and then to get each interior, I'm going to come down here and say 50, 40 then divided by the 30 angles that it's broken up into, so that's 168 degrees each. So the sum of the measures, each interior and each exterior. And just remember that anytime you see exterior, it's always 360, no matter how many sides. In problem number 2, we had a figure that was 6-sided, and I did a little bit of prep work on this. For a 6-sided figure, 6 minus 2 times 180 is 720. Morning, Nick. I'm okay. 6 times 180 is 720. Then I looked at the figure in the picture, and it's got a 90-degree angle marked, a missing x, and then 4 other measures. So I set that up with the x plus 120 plus 97, 130, 150, 90, all equal to 720. When I put together all the measures that I could, I hope I'm right, I had x plus 587. You guys cool with that? And then to finish this, I'm going to take 587 away from both sides and find out that the missing area, or the missing angle in that, is 133 degrees. Sure. Erica, would you go hit one of the lights? Now in number 3, I did the same thing. I tackled it and I said, all right, I've got a 7-sided figure, so the sum of all the angles is going to be 7 minus 2 times 180, or 900. Thank you, sweetie. So all the measures inside of the figure for number 3, the only difference in this one is we've got a couple of x terms. We've got an x term. This is just me going around the figure and adding together all the measures. X plus 160 plus 2x plus 125 plus 110 plus 112, and so on. Now, when I put together on the left side, I can't undo anything related to this 900 yet. I got to put together like terms. X and 2x is going to give me 3x's. And then I had it written on another piece of paper here that the sum of the rest of these is 654. So simplify that down. Now I can undo and take away the 654. So 3x's is equal to, oops, that's 645, 246. And then if I divide both sides by 3, I'm going to find out that the missing x is 82. And then these problems just asked for x, so I can stop off right there. If they needed me to tell what the measures were, 1 is 82 degrees, and 2 times that would be 164 for the other missing one. I do know that one of the questions on your test says specifically, once you know, like, you got to find x to go find measures. So just make sure when you're reading your test that you're looking out for that. In this case, we could stop at x. Number 4 is an exterior. The idea is to get the sum of the exterior angles, and anytime we see exteriors, no matter how many figures, we got 360 degrees. So I went around the figure and said 360 is equal to the 49, 7x, 83, 33, and 6x. And I simplified the 7x and 6x to 13. And 49 plus 83 plus 33 gave me the 165. I'm going to take 165 away from both sides. And I'm getting 195 equals 13 x's. When I divide 195 by 13, I get x is 15 for that one. I get x is 15. I'm just going to draw this on. Oh, wrong way, Nikki. I'm just going to draw number 5. You guys are finishing that. These are just in pictures on your page. We've got A, we've got B, and 101 degrees. B is going to be 101 degrees. It's across from the 101. This is just a little picture of what's on your document. A is going to be, it's consecutive with the 101. So it's going to be left over if we take it away from 180. So that's going to be 79 degrees. B is 101, A is 79. 6, we got a little bit more going on. If you got the problem done, you may want to just sketch it so it's together too, like on your line paper. First thing I'm going to put on my drawing is that I see opposite sides. I can relate. 18 is equal to A minus 10. I know there's more, but I'm just putting this on right now. So A is 28. And then I see inside, I've got a B plus 16 degree angle across from a 103 degree angle. And since those are across from each other, I can put them equal to each other. I take 16 away from both sides. 87. That one's actually going to be in degrees because it is related to an angle measure. Now in 7, this was diagonals. These diagonals sometimes are hard to see. You might want to like draw it bigger because it's sometimes hard to see what they're trying to put where. And I just find that if I draw it a little bit bigger, it makes it easier for me to label how they have stuff here. The 11 is just this part. The 14 is just this part. And then this piece here is going to be the C plus 5. And this piece is the D plus 4. So 11 equals C plus 5. C is going to be 6. And the D plus 4 equals 14. So D is going to be 10. I'm going to stop off there. I see some erasers and people taking some time. Do I put something liquid near my computer?
No. No.
Guess what? I'm going to set it down on the book over here. I know, right?
Yes.
Yeah, there wasn't many people that didn't seem to have heard about my little faux pas yesterday. Yeah, right? Number 8, you guys. Find the coordinate of the intersections of the diagonals. Now, in number 8, okay, so I got a lot going on up here. This isn't 8. I got 9 even ready to go. I did some math over here for number 8 just to show you mathematically how I could do this, but I really didn't have any issue with you guys just going, okay, once you've got your parallelogram graphed for number 8, the diagonals, if I connect them carefully, the point of intersection for the diagonals is right here, and that's sitting at -2, -1. Now, the mathematics that you see me doing over here is actually using the points R and T, and I calculated what the midpoint was. Because if you guys remember right, in a parallelogram, the diagonals bisect each other. Diagonals bisect each other. And so if they split each other in half, I thought, well, that means then that they hit each other at their midpoint. And I just did midpoint calculations to make sure they were the same. But you could just draw it too. I had no issues with that. Number 9, they give us 3 vertices of a parallelogram. They set up like this. These questions, make sure you're reading what they're asking for. It's parallelogram JKL. And they want us to figure out where M would be if this was a parallelogram. There's a couple ways that you can go about trying to figure it out, but I'm going to sort of use one of my simpler ways. I know M is going to be down here related to L, the way that K and J are related to each other. And from K, if I go up 1 and left 4, I'm sitting at J. I can use that idea. It's not slope or anything. It's just me sort of counting. I guess it is slope. Up 1, to the left, 2, 3, 4. That's where my M falls. And then if you take your ruler and you connect them, you'll see, okay, that's a nice, pretty parallelogram. So you plot the 3 that are there and figure out where the 4th one would be if it's a parallelogram. So my idea of doing a slope of 1/4, I was actually going to the left, it'd be -1/4. That even speaks to how these two sides are parallel. But M is sitting at, so the question really is, where's M to -2? Now I'm going to go back to my line paper for number 10. And I think we are on section 7.3 now. I didn't even mention the stop on 7.2. So section 7.3. So for this one, 10, 11, and 12 state which theorem you can use to show that the quadrilateral is a parallelogram. I really am more interested in what's the way. And on this, I see they're showing us that opposite sides are congruent. And again, I don't care about a theorem number. I'm more interested in the idea. And number 11, showing diagonals bisect each other. So these ideas are just coming off that list of 5 ways in section 7.3, how to prove something's a parallelogram. And number 12 is showing opposite angles congruent. And again, these ideas are coming off that 5 ways to prove a parallelogram from your notes packet. And that is on page 208 in your notes packet. Miss Merrick and I are tossing around the idea of letting you use your notes packets on this test just because there's a lot of ways to do stuff and a lot of formulas, or a lot of theorems. Going on to problem 13. Nice thing about 13 before I go over to my paper is that I see on opposite sides I have 4x plus 7 and 12x minus 1 across from each other. And then I also, my y's are across from each other, my y plus 1 and my 3y minus 11. So for 13, the 2 problems I'm going to solve are the 4x plus 7 equals 12x minus 1. That's the top and the bottom of that parallelogram. And then the left and right of my parallelogram is going to have me setting up y plus 1 equals 3y minus 11. And the directions say find the values of x and y that make this a parallelogram. That's going to make the opposite sides congruent. I'm going to start solving for x by taking away 4x's from both sides. 7 equals 8x minus 1. I'm going to add 1 to both sides. 8 is equal to 8x. When I divide by 8, x is 1. On the left, or for the y's, if I take 1y away from both sides, it's going to leave me with 1 equals 2y minus 11. When I add 11 to both sides, 12 equals 2y. When I divide by 2, y is 6. When y is 6 and x is 1, those opposite sides are going to be congruent. Now in 14, just a solving for x, and this one has diagonals in it. Diagonals idea, and all we have marked here is that these two are the same, and then this one is 6x minus 8, and this one is 4x. So they bisect each other. So 6x minus 8 equals 4x. When I take 6 x's away from both sides, I have to get all the x's on one side. Negative 8 equals 4x minus 6x is negative 2x. That negative divides out, x is 4. And then last but not least, we have a graph to show that the given vertices are a parallelogram. I'm going to move over to my graph paper for that. So you should have it graphed. We'll look at it together here in a second. Cool. So this is a parallelogram. I like doing just opposite sides congruent because the distance formula is something that you guys have gotten really good at. Opposite sides congruent. So let me try to show what WX's length is. WX and ZY should be the same. Let me go grab those points. Those guys are across from each other. WX is negative 1, 6 and 2, 8. How far apart would be 2 and 3. ZY, Z is 1, 0. Y is negative 2, negative 2. How far apart? I got 2 and 3 again. ZX and ZY are going to both be the square root of 3 squared plus 2 squared. 9 plus 4, square root of 13. That math lets me mark those congruent. And then I go do the other sides. WZ and XY. hopefully those left and right sides in my graph are congruent. WZ is -1, 6 and -2, -2. How far apart? 1 and 8. XY, 2, 8, 1, 0. How far apart? 8, 1. Same thing. Square root of 8 squared plus 1 squared. 8 squared is 64. 1 squared is 1. Square root is 65 for both. Since these opposite sides are the same measure, I have just shown that this is a parallelogram. With WX congruent to ZY and WZ congruent to XY. WXYZ is a parallelogram. So I've got my math and I've got my conclusion.